Good morning to one and all. Today I am going to teach about concept of frequency in discrete time signal. The discrete time sinusoidal signal can be expressed as a function x of n is equal to a cos omega n plus theta. The limit varies from minus infinity to plus infinity. Here n is the integer variable, a is the amplitude of the sinusoid signal, omega is the frequency in radians per sample, and theta is the phase in radians. Here first we can substitute omega is equal to 2 pi f. This formula we have already known. So you substitute omega is equal to 2 pi f in the above equation. So you will get x of n is equal to a cos 2 pi f n plus theta, and the limit is the same. Here this diagram is the example of the sinusoidal signal where omega is equal to pi by 6 radians per sample. From this diagram we have three cases. First case, that is the discrete time sinusoidal signal, is periodic if its frequency f is a rational number. That is, if a discrete time signal is periodic means f must be a rational number. That is, x of n plus n is equal to x of n for all n. Here the smallest value of capital N is the fundamental period. Next, for a discrete time sinusoidal signal with frequency f0, we have the condition cos 2 pi f0 into n plus n into plus theta, that is equal to, this n is multiplied inside, so we have cos 2 pi f0 n plus theta. This condition exists only if this is satisfied, this relation is satisfied, that is 2 pi f0 capital N is equal to 2 k pi. From this we get frequency f0 is equal to k by n, that is f0 is the ratio of two integers, that is k and n. Second case is, that is the sinusoidal, discrete time sinusoidal signal frequencies are separated by an integer multiple of 2 pi which are identical. We can take one example, that is a sinusoidal signal cos omega naught n plus theta. This cos omega naught n plus theta can be, that is, we have to add an integer multiple. So we have to multiply this, add this omega naught by 2 pi. So cos omega naught plus 2 pi into n plus theta. So we get it as, you multiply this n inside, you will get it as cos omega naught n plus 2 pi n plus theta. Here cos 2 pi value is 0, so you will get cos omega naught n plus theta. For k value we can define as xk of n is equal to a cos omega kn plus theta. This k value, k can be from 0 to all the numbers, where omega k is equal to omega naught plus 2 pi k, and the limit is from minus pi to plus pi. Next, third case, highest in discrete time sinusoidal signal, highest rate of oscillation in a discrete time sinusoidal signal at times when omega is equal to pi or omega is equal to minus pi. We know that same example only we are taking, x of n is equal to cos omega naught n. We can take it x of n it as x1 of n and x2 of n. x1 of n is equal to a cos omega 1 of n, that is equal to a cos omega naught of n. x2 of n is equal to a cos, in the omega 1 place you can substitute omega 2 of n. So you will get a cos, this omega 2 can be written as 2 pi minus omega naught into n, that is cos 2 pi is 0, so you will get a cos minus omega naught n, that is cos of minus theta is cos theta, so you will get it as A cos omega naught n, that is equal to x of n. So the condition is satisfied. That's all. Thank you.